I'm very pleased to now introduce our speakers for tonight. First of all, Eric Wittner. Eric is the City Engine and Procedural Technology Product Manager at Esri. He works to expand public understanding of how Esri's 3D products can enhance an organization's products and process and help them succeed. He spent 6 years on the 3D software development team, and he has been the product engineering lead for geodesign, knows how Esri tools can be used to support interdisciplinary decision-making in a variety of fields. He has also served as a volunteer firefighter in the Fall River Valley region of California. Eric holds a BA in Environmental Planning and Master's in GIS from the University of Redlands. I'd like to also introduce Rex Hansen. Rex is a product manager for the ArcGIS runtime software development kits at Esri. He has over 25 years of experience in GIS, spatial analytics, and computer mapping. He has been the lead product engineer on Esri products built on Microsoft's development platforms, and before that, product lead for .NET clients. And he has recently shifted to guide the development of technologies in the GIS industry to use authoritative geospatial data in immersive mixed reality experiences. He also taught for 5 years here in the MS-GIS program at U of R. Rex holds a BA in geography with minors both in math and in physics, and an MA in geography and GIS, both from the University of Arizona. We're very pleased to have these speakers here tonight, and so let's give them a round of applause.
Is this on? Okay, good. Okay, thank you for having me. Excited to talk to you guys this evening, and what we wanted to talk about is AR and VR. Give you a little overview of how we're approaching AR, VR as an organization, what it is, why we feel it's important, what people are telling us is important, and why, in terms of our customers, and why they're interested in implementing it. And then kind of open it up at the end and have a little conversation about AR, VR, and see how you guys or get your questions and interest in AR, VR. I'm going to start with a little introduction and go through some core technology, terminology, so we're all on the same page when we're talking about VR and AR. So what is it? Virtual reality versus augmented reality. They're both immersive technologies. They're both ways of experiencing 3D or even 2D information in kind of an interactive way. But really one is about being someplace where you're not. You're in a virtual reality, and the other one is enhancing the world that you're in with things that may not be there, additional information that may not be there. So this is just an example of two data sets. It's San Diego, but we're seeing it in one case virtual, where you have a headset on and you're seeing projection of both eyes, or you're throwing it into your world and actually walking around it in a physical way. So virtual reality is being kind of emerging as a new way of experiencing games and in the entertainment space, but it's also being used extensively by people like urban planners to give people experiences of designs that don't exist yet. So it's about being someplace that you can't physically be because you're too far away from it, being someplace that you can't be because it doesn't exist yet, or being someplace that you can't be because you're experiencing something that's fantastic or doesn't really exist. Augmented reality, as I mentioned, is throwing things virtually into the world. If you imagine you're looking through a window, and in that window you can see the world that you're in, and then you're overlaying additional information on top of it. So you're interacting with the outside world and enhancing it. There's a variety of AR applications that have already been released. I think the one that people are most familiar with is Pokemon Go, which was basically using augmented reality as a way to create a game where you would interact with things that aren't there, chase things that aren't there, capture things that aren't there. It was a very, very simple implementation, but it's evolving and getting better. So as people start playing with this technology, they're starting to integrate things like machine learning, where now the AR application can figure out what's obstructing the view, right, and respond to that. It can use the camera to detect where people are, and the things that you're projecting into the world can make intelligent decisions based on the things that they're seeing. So here you have two little creatures. They're interacting with each other. You'll notice they're dodging people's feet. When someone walks up and gets close to them, right, they get out of the way. So they're actually building in some smarts and intelligence in how they do it. So it's not just a passive projection into the world where you're looking at a piece of data. It's actually interactive things that can kind of respond to what you're doing. And the key to this technology is all about position. So you have to understand where you are in order to actually position those things appropriately in the world, or you have to make it smart enough so that it can decide its positions on its own. And there's a variety of ways to kind of get access to position information, GPS obviously, and that's what Pokemon Go used, but then you have some positional issues. And so for things like games, right, low-level accuracy is pretty good, but as you start doing more serious work, you have to look at doing higher-level accuracy because you might have dire consequences if you, for instance, misplace a gas line and you're trying to dig there. So there's virtual reality, augmented reality. There's also mixed reality, which is where you're combining these two things together. So you do have that head-mounted display. You do have that immersive experience. And you're projecting into that something that doesn't exist and blending those two things together. So something like Microsoft's HoloLens or Magic Leap. And this is an example where a person's wearing that headset and they've got a proposed development plan that's coming from a city, and they're projecting that into what they're looking at so they can see what will be there. What will this look like when someone actually builds up to the maximum allowable development of this area, and then make decisions about that. And again, position is key for this, because I'm trying to overlay something in the real world with something that doesn't exist yet, so I have to understand precise location. But there's multiple ways of establishing that location. In this case, you could, for instance, have a tag on the ground that you look at, it references it, as Jack is right here, right? And once it's got its reference, the mixed reality of the components that are being projected stick to that, so to speak, and then you can kind of move around them, and it does it all through head tracking. Or it could be that you have a set of devices in the room that are providing tracking information back in. All these things combined are really called immersive computing, or referred to as XR. And the reason why people are interested in it is because it's a more intuitive way to interact with information, especially 3D information, because we all move around in the real world, we all look around in the real world, we all understand that inherently from being a toddler on. So if you can provide people with a way to access that information in that way, it's fundamentally easier for them to use. Plus, it can be more compelling because rather than looking at a screen and scrolling with your mouse, right, you can actually interact with these features. Augmented reality really had its breakthrough with Pokemon Go, but really where it's driving now and being developed more is in real games, real applications, or at least where we're seeing the interest is in real applications that deal with things like utilities or urban planning. Virtual reality has also exploded with the advent of commercially available devices like Oculus Rift or the PlayStation VR, where like anybody for not too much money now can get access to a pretty high-end virtual reality device and build games. A lot of times people say, well, you know, it's great, but it's so hard. I have to be a developer to engage with this technology. I have to be a developer to create these experiences. And that's actually not true. There's actually some really low barrier VR experiences that everybody has access to. Many of you probably have thrown on a headset at some point and gone through a 360-degree movie or gone through a series of panoramic photos in 360. And it's not all super high end. There's very accessible ways to get to this technology. The other thing that I just want to point out is that the terminology is not all set yet, as this is all emerging and all changing. So these terms are changing every 6 months, and they get more refined and better ways of describing what's going on as we go. So I want to touch on a couple key terms when we talk about VR, AR, and MR. First of all is experience, and this is what the industry is using to refer to these things, because rather than being a game, which is about play, you know, rather than being a map or a scene, right, I'm actually immersing myself in some way with something, so I'm immersing myself in an experience. And so that's the jargon that's emerging around it, and that people are actually using this to refer to things. I'm sharing an experience with you. That experience is of a new building that's going to be built on campus that you get to explore virtually. There's a lot of different types of VR, and they all have different levels of capability. At the lowest end, you all have a VR device probably in your pocket if you have a smartphone, right? They actually have VR capabilities built into it. It's got a broad reach. Everybody has it. The graphics, though, are a little bit limited in terms of what it can see and display. The bandwidth can also be limited because you might not have a connection all the time. And generally, they're only going to give you 3 degrees of freedom in terms of how you navigate and move around, so it's not like a fully free level of movement. In the middle is that console VR experience, like PlayStation VR. It's really easy to use. It's focused on entertainment. You know, all the kids are going to be trained on how to use it, but the problem is that it's a walled garden. So from a business perspective, it's a great place to make games, but it's not really a place that you can make professional applications that you can then share with people because they're narrowly focused on that entertainment market. And then there's the high-end systems, the HTC Vive, the Rift, that are a little bit more expensive. They can be complex to set up and build technology for, but they're the most powerful. They give you the most freedom of movement, and they usually come with a collection of input devices that really kind of give you the biggest freedom in terms of the experience you can build. And they have all these advanced capabilities because usually they're built on top of gaming engines. The other thing to consider when you're thinking about VR is what's the scale of the thing you're building? Is it seated? Is it standing? Is it room scale? This is pretty critical because if you give someone a room scale VR experience and they don't have a clear empty room, right, they're going to run into something and hurt themselves or collide with their TV. It's like, you know, when, what was it, the Nintendo Wii first came out, people kept throwing their controllers through their TVs. Like, there's similar set of dangers and concerns with that. So you have to figure out how you're going to constrain it. Another way to constrain it is to make it a tabletop experience. This is really common in mixed reality, especially or augmented reality, where you actually throw something down onto the ground or you throw it onto a table, and then you can interact with that space and walk around it. But because you're focused on a single space, you're going to be working together and kind of constrain your moment a little bit. And that's really good for a collaborative experience. And so here's just an example of a group of people playing a game collectively at a table that's projecting 3D information, 3D representations of the game into a shared set of glasses as they play the game together as it's projected onto this table. So I mentioned position tracking for augmented reality and GPS and some of the challenges there. When I'm dealing with virtual reality, there's also some positional tracking. So the device itself can understand its position as it moves, right? So it's got tilt, roll, et cetera, and it's got inertial control, so as you move around, it's tracking what you're doing. It could also be that it's getting that information from outside in. So it may be that I have cameras mounted in the corners of the room. Those cameras are watching me, and they're watching my gestures, and they're watching my headset and my controls. And that's what's telling the experience what's going on and tracking it. So there's multiple ways of understanding position. If you're in a virtual environment, or even in a mixed reality environment, you may want to have different modes of locomotion. The easiest one, of course, is walking around, but at some point, if you're in a virtual world, like a virtual city, you're going to run out of room. So you need some way to kind of either constrain that or an additional way to move. Movement is actually one of the kind of more, I guess you could say, dangerous things when it comes to virtual reality specifically. Acceleration right now in virtual reality has a strong impact on nausea. The quicker you can accelerate or decelerate, the more likely you are to wind up throwing up after using it for 15 minutes. And so this has kind of been an interesting thing to watch in the industry as people have been building experiences that actually forego all movement, right? So you have a single point of location, and all you can do is look around. Or they move to a teleportation model where I can say, I'm going to go over there, and you zoom over there, but there's no acceleration and no deceleration, which is what actually causes all the disorientation. And then a few are using artificial locomotion, so they might be using a gamepad, but that's, as I said, anytime you have acceleration, you're going to have some issues. And then there are a few that are using other techniques for how they're managing locomotion. There's a variety of input devices now that are being connected with virtual reality and augmented reality, mixed reality. Hand controllers that allow you to point things and hit buttons, virtual guns, touch pads, something like the Magic Leap, where it actually has hand tracking and you have gesture control and you can do things or interact with things simply by touching your hands. And then on the higher end, they have those omnidirectional track pads where you can actually walk or run in any direction, and that's the way of your motion. And then the most recent one that I saw that I like is this, for lack of a better term, butt controller, where you sit in the chair and then how you lean your derriere controls how you move through the world, which is kind of an interesting way of developing a seated application. So in terms of who's using these things, actually I'm going to invite Rex up to talk a little bit about some of the applications and some of the uses.
Great, thanks, Eric. And thanks, James, for the introduction earlier. I just want to take a little bit of time here to, now that we've gone through some of the terminology, is take a little time to talk about maybe some of the uses and some of the use cases and the market actually around some of these capabilities. So first, though, just kind of a single slide here that brings in all these terms into one place, right? So we're talking about XR, extended reality experiences. And what we've got here is really a mixed reality spectrum, right? On one side, we're entering into the AR realm where we are looking for an optimized presence, where we have our physical reality and we're bringing digital content to us. On the other side, we're looking at, or we're basically teleporting or being transported to a digital experience, right? Another digital reality. And so on both of these endpoints of this mixed reality spectrum, what we're looking for is entry points, places where folks can start taking advantage of augmented reality or virtual reality at a price point. So looking at being able to utilize devices that provide maybe a lower end experience but are cost effective. And then as we move to the middle or look for an optimized experience here, we can take a perfect mix of both immersion and presence, both on the AR and the VR side, and we get a perfect mixed reality experience. We have a set of devices that are oriented towards providing those types of experiences. And so on the tips of this mixed reality spectrum, we might find things like mobile phones, mobile devices, devices that you already have in your pocket, right? And being able to leverage those devices in a way that allows you to participate in this extended reality experience, this mixed reality spectrum. So being able to pull out your iPhone and be able to use that iPhone as maybe a window to digital content that exists around you, maybe pipes below a floor, infrastructure behind a wall. On the other end of the spectrum with VR, being able to take your phone out and put it into, let's say, a Google Cardboard or a simple sort of easily accessible device or headset that then you can experience a VR. You can be teleported to another location. Near the sort of the middle of the spectrum, as we start to find that perfect balance, that sort of optimal area, we're looking at devices that are more oriented towards optimizing that experience. And so when working with things like a holographic device like HoloLens or Magic Leap, the idea there is really providing, honoring your location, but at the same time providing a more immersive holographic experience, right? And it's really dedicated to providing that experience. It's not necessarily used for something else. Those devices can be fairly expensive, so there's obviously a price point you need to consider there too. On the other side of that, when working with truly immersive devices, generally those require quite a bit of horsepower, quite a bit of, and that horsepower comes at a cost. So if you're looking at like an HTC Vive or an Oculus Rift, being able to invest in something like that, which is dedicated to a VR experience and providing that premium VR experience, can take some time and is really oriented specifically for providing that experience at its most immersive or most optimal level. What's interesting here is that we do find that there are some situations where we see a blending. So Eric talked about the difference between a mobile VR device, console VR device, and really a premium VR experience. What we find is that we have a lot of chipset makers like Qualcomm who are partnering with vendors to be able to build out a mobile or low-cost mobile VR experience that can take advantage of take advantage of your presence, so that instead of a 3 degrees of freedom where you're just back and forth, you have 6 degrees of freedom where it honors your location of your head or as you move around at a lower price point. And so we see some blending there between these different device levels. So something to keep in mind, this is just a kind of an overview of the terms and where they fit within the spectrum and devices that are available to meet some of those needs. But what we're finding now, at least in our space, with working with organizations that are leveraging or that have geospatial data, and they want to be able to take advantage of that in a better way. And so most of these organizations, large and small, are looking to take advantage of their data, of live and local authoritative GS content that they have available, and using that somewhere within the mixed reality spectrum. There's a number of challenges that are coming up here, and we'll talk about some of the opportunities here. But some of those critical needs to enter into these opportunities, these experiences include, with virtual reality, obviously we need a high fidelity. You know, Eric talked about motion sickness and being able to provide a solution that is a good experience that doesn't compromise the user's ability to function apart from the virtual world, right? So being able to provide a cost-effective solution that still enables those users to be able to utilize a virtual experience. Augmented reality, positional accuracy. We talked about some of the capabilities, some of the technologies that are being used today to try and provide a better position. If we're talking about presence, position is important when dealing with augmented reality. You want to make sure that your location is honored relative to your geospatial information. You want to make sure that the pipe that you're trying to avoid when you're digging is in the actual location that you see it in, right? And so there is an element of positional accuracy that's necessary there to make accurate and well-thought decisions. Of course, cost effectiveness is key, right? When you're talking about delivering these solutions, you need to make sure that you can deliver them at scale. And so many of these businesses are looking for ways to enter into the spectrum without spending a fortune. So what are we seeing in market trends? So a couple things. Obviously, there's a number of different organizations out there that provide statistics on the popularity or the future of VR and AR capabilities. These are just a couple of snapshots. In this, we're talking about, or this graph really shows an estimation of the market size or market share with respect to VR and AR applications going out to 2025. And they're talking about different industries on the AR side, such as integration with healthcare, engineering and real estate, military, defense and intel, and education, and seeing that those areas, those industries will grow or will find that there is a benefit to taking advantage of AR experiences. On the VR side, a lot of this is focused on gaming today, but what we're finding is that there are a lot of different business applications where folks want to take advantage of VR experiences, and we'll take a look at that in the next slide. This is another example here of just virtual reality revenue by segment if we're talking about the hardware that's being sold to be able to deliver the VR experience versus the software that's being built on top of it. We can see out to 2020, we're talking tens of billions of dollars and a major growth actually within this area, being able to provide a solution that meets the needs, at least in the VR segment. If we take a look at both VR and AR, this is a fairly aggressive projection, but what we're seeing here is a $38 billion market in VR. We're seeing an AR market that's 5 times that size, just because of the ability to sort of relate to, you don't necessarily have to worry about the virtual fidelity, but what you do need to worry about is positional accuracy. And a lot of the capabilities there and leveraging devices that you have in your pocket today and being able to make that available so that you can enhance your current experience applies to so many different markets at this stage. Obviously, if you're looking at enhancing your experience, you're looking at obviously enhancing that with some of your real-world geospatial information. And so what are some of the trends that we're seeing in GIS today? Who are we working with? In the last 2.5 years, since we've started really reaching out and working with a lot of customers in the AR and VR areas, or customers looking for leveraging those capabilities, we've talked to about 150 customers in a variety of different industries looking for ways to take advantage of their data. So if we take a look at VR, a lot of that information, or a lot of those requests are coming from folks that are working in education. Or in, with respect to education, we could be looking at, let's say a park service is looking at being able to provide their constituents or people that attend the park or that participate at the park with an enhanced experience there so that they can experience that without actually having to come to the park, right? Education might be, well, you want to be able to provide someone with a remote or teleport them to a location that gives them an experience without having to travel or the expense associated with travel. Same thing goes for planning. In this case, there could be a scenario where with planning you want to be able to provide a set of decision makers or constituents with an idea of what might be built actually in a specific area and give them an idea of what it might look like on the ground or from a specific perspective. Same thing with training, providing folks with an idea of when they get to a location, what they might be experiencing. So what we're finding here is that mobile is fairly popular in the sense that it's cheap. It's easy to distribute, device is already in your pocket. Let's provide someone with a headset like a cardboard for $5 and maybe we can make that work. For premium experiences, which are a bit more stationary, they're looking for ways to be able to take advantage of, maybe within an office or an enterprise, being able to survey or provide an experience for their employees without having to pay for travel. So a lot of, but also looking for the best VR experience possible so they get that fidelity. Within AR, or mixed reality experiences, obviously the big value add here is field operations. When folks are working with, and our customers are working with their data in the field, they want to be able to enhance their current experience with their current presence with their digital content. Instead of having to abstract from a 2D map to reality, they want to be able to overlay that information on top of their current experience, the current physical reality. That physical reality could come from a camera feed, or it could actually come from, let's say, just looking through a lens and being able to supplement their current experience with holographic content. And so what we find here is that handheld devices are quite popular because most of these organizations already are using handheld devices in the field to manage their resources in some capacity. So being able to enhance that workflow is pretty key, and it's also still cost effective. Head-mounted, for those folks who are looking at sometimes providing a brand new workflow, and they're willing to spend some of the time and the money to invest in something like a headset that's dedicated to a specific field workflow, such as purchasing a HoloLens for $3,000, and then investing the time to build out a solution that allows you to see that information. That might be important enough for them to be able to leverage because it's impactful. Great, so what are we seeing? So in some of these areas with education, there's a number of different, and these are just some examples of customers that we're working with right now. Folks in VR and education. I'll mention this, NASA actually is the first customer here, and they're looking at being able to take advantage of some of their atmospheric or climate data and presenting that as a way of educating the public about how these climate change activities can affect different points on the Earth. The next item here, we're talking about electric infrastructure, changes to affected communities, organizations that are looking to enhance or change, let's say power lines, add new power lines, or change infrastructure within an area, are able to deliver an experience to their constituents that allows them to visualize what that change might be. What that does is it eliminates the need to have to go to great lengths at different sort of community gatherings to try and convince folks that this isn't going to be as impactful as it might be, but they can actually provide them with an experience beforehand, saves time, saves money. Also, I mentioned this before, but enabling visitors to augment their experience. So in education, being able to augment that experience with points of interest, right, without having to put up physical signs, but being able to change that information on the fly digitally, right? So something that we've seen a number of different organizations who have this data available today, but being able to provide that in a really a heads-up experience. On the planning area, obviously this is folks being able to deliver digital plans in a way that are meaningful to constituents or decision makers in those areas, whether it happens to be transportation networks or new buildings, a variety of ways of doing that. For training, we've worked with a number of agencies that are looking at, try not to move my jacket, are looking at ways for their agents to understand what type of experience they're going to have on the ground as they're en route, right? So being able to leverage existing devices that they have in their pocket, not carrying a HoloLens in their briefcase or in their backpack, but being able to take their smartphone out, be sent really a mission plan, and being able to see that heads up and get an initial experience so they're prepared, they're at least initially prepared when they hit the ground at that remote location. That's something that we've seen a number of different situations come up. Obviously, there's another one here, preparing firefighters to fight wildfires, which might be very appropriate here shortly. And that is giving folks the ability to experience what it might be like, sort of teleporting to a location where a fire is occurring and being able to respond to that, or being able to go into the field and see where things are moving or how they're moving, even when they can't see them physically. Field operations, the last part here, this is incredibly important, and I would say that at least with respect to being able to build out AR experiences, this is probably our most critical industry here, and that is being able to take advantage of or work with different industries that work in the field, utility companies, oil and gas, folks that have resources that are important, that are managed in the field, and be able to see those in a display that allows them to leverage the devices they have and manage or manipulate those features while in the field. And so being able to get a more accurate picture of what those features happen to be. With that, I'm going to hand it back to Eric, and he's going to take us through some of the experiences that we have with ArcGIS.
Thank you, Rick. Yeah, so we've kind of broken this down into two parts. One is looking at experiences and solutions that we deliver in whole, and the second one is looking at tools for building experiences that we provide a framework for. So I'm going to start by talking about GIS data in VR, AR for mobile devices. So one of the things that the customers asked us is they wanted a very simple way to create a VR experience with just a couple clicks that they could then share with someone. So in this example, what I've got is I've got a building model, could be coming from CAD, could be coming from BIM, and I've got a redesign of that interior of that building that I've proposed for a customer, and I want to give them a way to experience it. Now this is a web-based version of the viewer, but if you imagine you were looking at it in a heads-up display, right? So we've shared that, it's got known locations. Now I'm inside that, I put on the headset, I can look around. I've got these different viewports. When I look at one, I can tap and I zoom to that, and it gives me this kind of first-person experience of it. It's built actually with just a huge collection of spherical photographs which are cataloged together geographically so that they know where they are in reference to each other, and they position the little icons for zooming between them based on those positions. I can flip between different scenarios to compare them, right? And it's really, really simple and easy to create because it's just saying click OK, create a little file, share it up onto ArcGIS Online, and then I can download it to my mobile device. And this was actually built for Samsung Gear VR, which is just a device that you drop the phone you already have your Samsung phone into, and you've got your little VR headset. And now we're making a web-based version of it that's targeted at cardboard, so anybody who has a smartphone with a browser can hit that, get that side-by-side view, drop it in a $5 cardboard, and get that same VR experience with a really, really low barrier, threshold barrier for use. And it was targeted at a couple use cases. One is delivering a really, really simple VR experience to the public for planners. So this is a proposed design or a set of proposed designs for some new buildings. So if I'm an architect or a city planner and I've got some proposed designs that I want to share, and I want to say, look, we're not sure if we should build this. It might impact you. Go to the resident, hand the resident thing, and say, here, look from your window. This is one of the things that we're proposing. How do you feel about that? Do you like that? Do you dislike that? You've got a nice view onto this park. Like if we look at the alternative, you're going to lose some of your view to that green space. Do you like it or do you not? So it's an engagement tool and a feedback tool that they're using to actually talk to the public. Another example is Augio, which is another lightweight app that we made as part of our Esri Labs efforts. It's basically a mobile augmented reality app that again runs on your phone. It's completely out of the box. It's easy to set up. It's available for both iOS and Android. And what it actually does is take geographic information and then project it in the real world. So you publish a service, and then it uses the position information it already has to project that information out into the world. So just to give you an example, and ignore the guy with the laptop on the left. He's just there because that's the only way we can record the screen. It's not running off that laptop, I promise. But you see as you turn and you look at an object, right, there's a database of features and items that exists for the facility. When you stop and get close to one, it expands and you get a picture, or you get additional information and attributes about that feature. So it's a way of kind of overlaying spatial information into the real world. Those are kind of the really low-end mobile-based applications. So let's talk about the higher end. Let's talk about GIS data in game engines and building game engine-based virtual reality and augmented reality. So what is a game engine? A game engine is basically a suite of tools used to build experiences. So it's a rendering engine that works in 2D and 3D that can produce really, really high quality graphics. It's a physics engine that actually physically models the world, right? It has collision detection, so you can't magically fly through walls, and it's kind of managing your movement. It can have audio components, including spatial audio. So I can create a sound, and I can put that sound in a location. As I get closer, it gets louder, right? It does animation, so I can actually animate scenes. It has all this complex lighting effects. You can back it up with machine learning or artificial intelligence to have agents inside the thing make decisions, like butterflies, they're going to fly in a specific pattern, right? And then it supports all this kind of cinematic production, and then has all the back end to do that, the networking, the memory management, all that you need in order to create these experiences. And the great thing about Gaming Engine is someone has done all the hard work of building that for you. And you don't have to do it again. You just have to utilize it and build on top of it. And so that's why it's such a nice way to do it. People think about gaming engines for games, but it's not. It's gaming engines are for building experiences. And if any of you have seen a car ad in the last 10 years, you've seen a game engine, because many of those car ads are being built on top of game engine technology. And when we say experience, an experience is not necessarily a discrete tool. So in GIS, right, we think of discrete tools that can answer a question. So I have a line of sight tool. Can I see from here to there, right? That's very simple, but that's not an experience. An experience is I'm going to build a custom experience for identifying all the locations of a sniper in virtual reality when my agents are going to be going to a specific location. And I've customized that and created a unique experience around that that's tailored for the consumer. One thing, though, is game engines generally are not spatial. They're not geographic technologies. They don't understand location out of the box. So it can be challenging to use them when you intersect them with GIS, and this is what we've been spending a lot of time working on, trying to solve that. So there are two big gaming engines out there that are commonly used, Unity and Unreal. Both of them are free to develop on, so you can actually just go download them and start using them tomorrow and start playing with making experiences. You only pay when you publish. You only pay when you share with somebody else or you're trying to sell something. So it's a readily accessible technology. This is an example of a little Unity game. So it's side by side, 2 eyes, virtual reality. And what we've done is we've dropped a set of proposed development and a changed streetscape. This is actually in Redlands, near the downtown area, and then made that available as a Unity game that you can navigate. And then what we did is, there's a lot of like tricks in terms of gamifying experiences. So you'll notice, like right when I start, you see that little gold coin that you went by. So we scattered gold coins throughout Redlands, and then if you collected them, you got a certain high score. So you're kind of tricking people to wander around and explore things in a game way, but they're actually exploring the change that you're proposing to the city, so they're getting the experience at the same time. So that's one of kind of the interesting ways that we can use games to engage. The other big game engine is Unreal by Epic Games. We've been doing a lot of work with them lately. They're the inventors of Fortnite, which some of you may have heard of, so they have more money than anybody else on Earth, it seems, at the moment. And that makes them a really fun partner to work with because they're willing to put a lot of support and time behind it. In this case, we started working with them and HOK, which is a design firm. And HOK came to us and said, hey, we want to use Unreal as a way to render representations of conceptual designs in a city in really visually compelling ways. We want to use the game engine to populate it with simulated people so we can give it live, show people walking around. And the three of us got together and worked on creating this template for it. But what came out of it was the realization, well, actually, if these are like videos that we're producing, why don't we just make this into a thing that you can actively use and explore as a game immersively with a headset? And so we started working with them on developing an actual urban planning game, and this is the result that we've come up with. So I've got my representation, my 3D model of a city. I actually have 2 people with 2 controls, so it's a collaborative game. I've got the city down on my table. I can navigate it, rotate it, zoom into it, push it away. But again, I'm wearing a headset, so I can get physically down close to it if I want and look at it. So I have multiple modes of interaction and multiple modes of control. It's a virtual environment, so I can make changes to it. So I have multiple design scenarios. I can change between the design scenarios and see what the different proposed buildings that the architect has built would look like in that context and see their impact. I can start changing environmental factors. So I can change the time of day and see what's the shadow that's going to cast on the adjacent green space, right? And then I can actually take my friend and teleport down into it and say, let's go stand on this street corner and see how big is this building really? Is it going to be, kind of ugly and hideous? So that would be my comment on that building. But it gives them that kind of first-person experience. At the same time, right, being able to start build on and enhance these set of tools that we're doing here, where we start building in the analytic capabilities that we traditionally see at GIS and make them accessible in here, things like viewshed. I think Rex is going to show some cool viewshed examples a little bit later. And also being able to integrate the information we get from the planning perspective and start using that to populate things in the game. So for instance, in the first visualization, we saw people walking around. But if you control the number of people based on the design scenario, so the more people you have in a building, the more people you have walking around on the street. The larger the building, the more parking spaces, the more vehicle trips, the denser the traffic that you put into the area around that. So you actually start using the results of the GIS analysis and the design to drive the visualization and make the visual context actually guide people's experience of what this is going to be like. So with that, I'm going to turn over to Rex to talk a little bit more about VR, AR with ArcGIS runtime and how we're using the runtime technology to actually collect GIS information into gaming engines, and also how we can use GIS technology to build virtual reality and AR reality.
Good stuff. Perfect. Thanks, Eric. So now I'm going to talk about some developer text. I've ditched the jacket, actually, so we're good. Hopefully I won't bump it anymore, right? So anyone here have developer experience? Anyone think they've got developer experience? Has anyone touched a developer IDE? I see a little hand over here. Okay, good stuff. So what I want to talk about now is another offering. And so Eric worked through a couple of applications we provide, mobile VR, mobile AR, actually things that are really, right now they're prototypical at this point, and then some solutions there that the developers could take advantage of within a game engine. What I'm going to talk about is some additional developer capabilities that are available as part of the ArcGIS Runtime. ArcGIS Runtime is a developer SDK that gives developers the ability to build native applications. Think applications that run on your phone, your desktop, that take advantage of local resources. They're not running in a browser, right? So these are standalone applications that can take advantage of local resources, sensors, GPUs and such, and so they can take advantage of the rendering power and capabilities that you have on a device. We build, at Esri, we build a set of ArcGIS Runtime SDKs, and these are optimized for performance, and they include their own rendering engine, right? So we already support the ability to work with 2D and 3D as part of these developer SDKs. If you're a .NET developer building for Windows, iOS, or Android, or a Swift developer building for iOS, or a C++ developer building for every platform possible, we actually have a solution available for you today, right, to be able to build out these mapping capabilities. And we've had these available today, or we've had these in production for quite a while. What we'd like to do is be able to, I mentioned the spectrum earlier. The edges of that spectrum talk about really entry points into this mixed reality or this extended reality experience, and that is how do we target AR, VR experiences to be cost-effective solutions, and so that's really targeting mobile devices. And so what we're doing with Runtime right now is we're trying to basically take advantage of the 3D capabilities that we have in Runtime and enhance that so that we can build an augmented reality or virtual reality experience that target mobile devices, iOS and Android devices primarily. So right now we have a private beta program. So if you might not be a developer, but if you know somebody that is, or if maybe you manage a group that has a developer staff, we've got an opportunity to, as a developer, start working with this technology, this capability today. And I'm about to show you a couple of demos of some of the videos of solutions that our customers have built, some things that we've built, to showcase some of the capabilities that Runtime provides today that you can build out and provide solutions for both AR and VR. If you'd like, you can send an email to this address, actually, and request access to our private beta program. This will give you access to our developer SDKs for .NET, iOS, and Android. So if you work with a group, or let's say you manage a very large group of developers, I can see, right? So that's good stuff. You can have them enter this program. So there's a couple of things to think about. This is really, these are some examples here that we've had folks build out, and this really kind of showcases some very simple approaches to targeting AR and VR. This first option over here is a video on an iPhone. It's working with basically the voice API that's provided as part of the Apple Toolkit framework. And when you speak or when you say something, I'm not turning up the volume here, but when you say something, it'll zoom to a specific location on the Earth that matches what you said. In this case, we zoomed to China. And note here, it's almost as if this globe actually exists in physical space, right? So we can move around that globe as if it was content that existed in our physical reality, right? So digital content, nice and easy. This other one over here actually showcases using ARKit. So ARKit provides iOS devices of the appropriate minimal version, the ability to work with depth sensors on the device to be able to determine relative location or location of objects. And so what you see here is an example that shows different points that are being registered as part of ARKit. So it finds surfaces as part of those depth sensors on the device on your iPhone or iPad. And then it's also using basically, it's using a computer vision and image recognition to be able to determine what it's looking at and then labeling that, right? So this might be something in a collector environment where you're walking around and you visualize content, and through machine learning, you've been able to determine that there are specific types of features, and that's being written back to a database somewhere, and there's a position associated with it, right? So being able to automate that process. But being able to leverage some of the technologies, and in this case, machine learning, image recognition, computer vision, to be able to take advantage of that in an AR experience. So here's another example, and this is just a couple of screenshots of a customer that we have in Netherlands where they were using their mobile phone to get an idea of what it would look like in an empty field if they put in a new building. And so what they've done here, and this is an augmented reality experience where they've built out a building in 3D, and they're walking around where that building would be, and you can see, well, there's somebody outside the window, right? So we're seeing this is kind of blending this virtual content with their current physical reality, right? So an interesting idea there. This is an example here of, this is actually in the hallways at Esri where we've built out something that might be quite useful, and that is I want to be able to find a location, in this case on Esri's campus, and how do I get there? You know, give me some assistance here. I'm going to find that location first, and then allow me to provide a route. There we go. Gives me a route to how to get to that office, and then all I have to do is follow that route, right? Very practical, something that you'd like to see or maybe you'd like to use, especially as Esri's campus gets bigger, this becomes more valuable, let me tell you that, right? So something to enjoy, something to take a look at, obviously a very practical use. This is another example here of RNLI. They are a charitable organization in the UK and Ireland. They're responsible for handling events that occur. Whoops, hold on. Is that going to play? I might have to touch this one. Okay. Are you going to play nice? There we go. Okay. So what they've done here is they've built an application that works on a phone because it's designed to work with constituents, the public. And so what they want to be able to do is provide them with a device that if they witness an event offshore, they want to be able to find that event and relay that information using a special set of coordinates or values back to the RNLI so they can deploy emergency services. And so what they've done here is they've been able to build out a solution using runtime today that allows them to reach out to the public to be able to get additional information, which has worked out quite well. Here's another example, and this is kind of entertaining, but there is some value here. This is an example of this is actually an event that we had in the UK earlier this year. But what it shows is it's going to make me touch it again too. Okay. What this shows is AR, but it's collaboration. So what we have here is the city of San Diego, downtown San Diego. This is a tabletop experience, AR. We're looking at it on one individual's phone, right? Now at this stage, it's kind of a small scale experience, and we just had Godzilla walk on stage, right? So Godzilla's on stage. This is kind of dangerous. You know, what we want to be able to know is as Godzilla walks through the city, right, what can he see, right? And how can we collaborate with someone else who's maybe a third party to be able to see what Godzilla can see from his perspective? And so as they sync up these experiences, what you'll see is a view shed. And here we have an avatar of Godzilla walking through the digital experience. Right, so as he walks through this small scale sort of view of San Diego, well, there we go. Now we can see what's in green are things that are visible by Godzilla, what's in red are things that he can't see. Right, so this third party that's visualizing this can tell his friends where to run, right, or where to hide, right? Nice and easy, and we can see where Godzilla is. So what this really illustrates is really a collaborative experience, right? So we can work with not just geographic data, but analysis in the context of geographic data to make decisions. Great, so what I want to do now is actually do a real demo. So instead of showing videos, I've got an iPad. I'm going to disconnect here briefly. So this is an application that was written with our beta that was designed to, let's see if I can fit this in without dropping anything. Great. I'm going to start up an application here. So the key here is that I have, with this iPad, I have ARKit enabled, right? So this is an ARKit enabled iPad because it meets a minimum spec. I'm viewing a camera feed, and so I can see the audience, right? We'll move it straight. There we go, that's a little better. And what we can see here is that ARKit is starting to, is getting surfaces. We can see a set of yellow dots that are showing up. We can see surfaces are showing, right? And so the part of ARKit that enables us to get a surface, determine where that surface is working. What I'm going to do is I'm going to place some geographic data in this location. So what I have here is this is an integrated mesh. Integrated mesh really provides us with really think of a triangular mesh that includes its 3D data. It's presented with 3D context, and so it has depth, it has elevation, and it's colorized, right? So in this case, it's real color. So what I have here is I basically have a tabletop experience in AR. And so again, you can see I'm still got the camera feed. And what's interesting is I don't use my finger to move around here. I don't use a mouse to move around. I can move around this tabletop, this model, right, as I move around the room, right? So I'm still present, actually my physical reality, but I'm experiencing digital content. Now, anyone else with an iOS device can see the same thing, right? So we can collaborate around this experience. And if I want to zoom in, I just kneel down, I get in really close. I can hear my knee pop, that's nice. There we go. I can see Half Dome, fantastic, right? I'm on top of El Capitan, I think about right there. Now what's nice about this is, great, I can see digital content. How difficult was it? Did I have to take months building a physical model of this? And then if I had to change it, I had to rip it apart and then build it up again? No. I could do all this digitally. I could present it in a way that people can actually share and then use that and then see it change. But it's also dynamic. So let's say I want to be able to determine viewshed from a specific location. What I'm going to do here is I'm going to tap on a location, and then I'm going to turn on my viewshed. And what it will show me is from that point that I've tapped, it gives me basically a 120-degree viewshed. So everything in green I can see from that point. What's nice is as that viewshed rotates around, I can get a good perspective on where that point was that I tapped. And that was on top of a fairly high surface. And so we can see where that is. That's great. That's one visual analysis capability that then I can use, or I can further use my digital content. Another thing to think about here is line of sight. So let's say I use that location. I want to determine line of sight from a variety of different locations. So let's do this. I'm going to tap on a couple of different features, and then I'm going to move my point around. And as I move around, I can see whether or not that tapped point, which is what I'm using my fingers, I'm moving around, can be visualized from the location that I've set. And what I see on the bottom is a set of colors that indicate whether or not I can see that point from that location. What's nice about this is I can still interact with it, right? So I can still get down, I can still see what's happening, right? And I can also share, right? So I can share this with, other users of the application, right? Which is great. So a great way to take advantage of digital content, share that content, and collaborate around other types of visual analysis, taking advantage of what's available as part of our developer tech today. Great. Let's move this thing over. All right, back to the slides for a nice little wrap-up. So one thing to keep in mind is you could build that today. So if you want to grab the beta today, you could build that experience today. If you have the data and you want to take advantage of what's in the API, it's available. The last part, cool, thanks, Eric. Last part here is really touching on game engine support. So being able to take advantage of a game engine usually means having some sort of developer skill set. If you're using Unity, you're working with C# and scripting language. If you're working with Unreal, you're probably C++. But inevitably, that's where the power comes in, right? Being able to take advantage of your developer skills and be able to take advantage of what's in the game engine, right, to enhance use of geospatial data. So we saw some of that in some of the videos that Eric provided. But inevitably, what we'd like to do is expose this in a way that developers can take advantage of it, right? So they can work with live and local data, bring that data in and work with that more effectively. So this is a work in progress right now. But what we do have, in order to take advantage of some of these game engine capabilities, is a number of partners who've built out solutions. We've also built some prototypes. And so I just want to wrap up with 3 more examples here. This is an example from one of our partners that's working with a platform they've built on top of ArcGIS. So they're using ArcGIS platform data that we provide, tiles for display and elevation, features, and they're using these in the context of supporting utility companies, utility organizations. And so what's happening here is this utility organization, or a set of utilities, have invested time and money into holographic devices like HoloLens. And they would like to be able to take these devices in the field, and they want to make sure that they've got good positional accuracy. So they're working with our partner to make sure that that positional accuracy is good enough for them to be able to make decisions. Sometimes that involves purchasing a very expensive Bluetooth GNSS device. Sometimes that involves image recognition, working with what's around them that's well known, and being able to use image recognition, machine learning to be able to determine whether or not, or where their location happens to be. And that would be something that's relatively customized to their solution. But in the end, being able to provide a solution that allows their customers to take advantage of or visualize some of this. You can see there's a relatively expensive GNSS device there hooked into an iPad. Being able to take advantage of devices they have and devices that they purchase to be able to work with their utility data. So here's an example here of basically water lines, sewer, and being able to figure out where those locations happen to be within a community. Right, so what we'd really like to do here is make this not just purview of what our partners can do and custom solutions that are built on top of game engine clients, but something that allows for anyone, any developer, to take advantage of it. Next example here is another partner that is really using game engines to target mobile devices, right? And so in this case, he's got an iPad, he goes into the field, and he's got a set of feature points here. These happen to be assets associated with a local utility, and he wants to be able to use that iPad to be able to visualize some of the pipelines. Now, in this case, it doesn't have a GNSS device. I didn't want to pay the extra cost, so what they do is they use basically a ground truthing in the field. And so they have an option for being able to go to the field, know where things are located, use that as a reference point, and then everything else is relative to that location. So a couple of different options for being able to make that happen depending upon the cost associated with it. Now, the last thing I want to focus on here is actually a prototype that we've built, that Esri owns, that we've made available on GitHub. And so if, tell your developer friends that if they want to go out and take a look at some of this capability, what we've built here is a Unity solution. And so what we're taking here are tiles from ArcGIS Online for display, tiles for elevation. We're overlaying that on a tabletop experience. And so we're providing a tabletop experience. We're visualizing this through HoloLens. Right? So what's happening here is that we've got our gaze, which is indicated by the blue dot. And what you'll see here occasionally is an air tap. So obviously HoloLens has its own mechanism for working with gestures. And so here he'll air tap, and what we'll do is a geocode, and we'll pop up a little balloon there with an address, right? So what this shows is the ability to work with a game engine like Unity, building out a solution on top of live data for display and elevation, working with operations like geocode, and providing a nice tabletop experience without having to build a physical model, right? So this is something that you can manipulate and change. What's actually happening behind the scenes, the sound isn't on, but he's using voice commands to be able to zoom to different locations, actually. So the source code for all of this is available at this URL. So in case you guys are interested, or you know someone that is, something to try out. And I'll finish with that and hand it back to Eric.
Well, I think we'll actually open it up for questions.
There we go.
So yeah, we showed you a lot of technology and capabilities. Some of them pre-built, some of them out of the box that you can use. Some developer capabilities. The core places that AR and VR are living in terms of technology, from mobile all the way to the high end. Some of the uses of it. So yeah, we'd like to open it up for you guys to ask us questions, and we would like to hear like what you guys think of AR, VR, and how you think it might be used or might change places or businesses that you're touching.
Good stuff, yes.